Hi, Ray. How are you? Hi, everybody.
Hi, I'm good.
You received my form that I sent you a while back, right?
Form?
The form that you asked me to sign.
No, never got it back. The OBS thing? No.
Yeah, I sent it back to you.
Oh, that's weird. I'll double check, but I didn't notice it actually.
Okay, hold on. Let me check my email right now. Yeah, you responded.
I did?
Okay.
Oh, I can't even
Yeah,
remember. I must have been really tired, or I don't know. I'll
yeah.
find it.
I sent it back to you on. Oh no, you responded previously, but I sent it back to you on the 8th.
Oh yeah, you did. I didn't notice it.
Okay.
It's a
Just
good thing you
wanted.
brought it up. I completely forgot.
All right, just making sure that you got what you needed.
All right, thank you. I'll ask the other teachers.
Okay. I hope everybody's doing okay. Monday, right? It's just the weeks go by so fast. So
Yeah, especially at home.
well, yeah, everything at home is busy, but um, can you believe it? It's week 9 already, right? We only have approximately 7 weeks until the end of the course. So we're more than halfway there. Good job, everybody. Okay, so let me log on to Canvas. If you can, please log on Canvas and then download the notes and the assignment. We'll talk about that. So you only have maybe a couple more chapters to go in the book, and then we'll work on our project and our review for the final over the next few weeks. So we have one more unit, which is we're gonna cover unit 10. It has some content that would relate to what we're talking about today. And then after that, we'll work on our project. So we will have option to work in team, since this is, if you don't want to do team, you can also do individual project. Okay, so let's talk about what we need to program today. And the interesting part is that this is a very important chapter in not just your project, but in the future classes and also in programming itself, because it talks about class and object. It's a little bit more challenging to understand at first, but once you get a hang of it, it's going to be very easy. And if you take Java, this is the first part of Java, is to understand class and object. But with Python and other language like C++, you can get away with creating a program without getting into class first, but we want to have the structure. So today we're going to talk a little bit about class and handling exception. Okay, let me get my files open. Also, I will release the quiz review game by our next session and then our quiz. So you will have a complete week for the quiz starting from Wednesday. So I should be able to activate that soon. Okay, let me get my. So in Unit 9, we're going to talk about exception handling first, and then we will touch on our class and object. So in this week, we're going to cover chapter 16 and 17. And then next week, we're going to talk about polymorphism and how to work with the class and the object and inheritance. So we'll get into some of that next week. I have the next class file open, sorry. Okay, so to start, I'm gonna get into screen share. If you have any question, please unmute and ask. And I hope you were able to address your lab from last time. I'll take some questions at the end in case you have questions from the lab from last time. Okay, so in chapter 16, it addresses exception. And we have to be able to know how to handle exception, or ultimately what we see is we would have errors in the program. Especially when you're dealing with input validation. Let's say that you want the user to input specific value in certain range, and anything outside of that, we want to use exception handling to manage that in our program. Also, in some cases, you will run across errors. So I want to mention, going back to the first chapter, we talk about errors in the first chapter, but there are two things that you're going to see when you're working with the exercises today. Two of the main errors going to fall, or the errors going to fall into two main categories. Number one is going to be a compiler error, or the interpreter error, right? And as it goes through and interpret each of the line in your script, if something is not matching up to the way the format and the syntax, it's going to throw an error. The second area is that you would come across the errors that's going to fall into the runtime error, and we're going to see some of that today. So in some cases, so for example, let's say that, let me get my idle open here. So this is shell, right, in idle. And if I'm trying to, let's say that I have a variable called num is 5. And I'm trying to print num like this. And when I press this, nothing is going to happen. We know that it's a syntax error. Or let's say that I do this, right? And it's just going to tell me num. So we know in the back that that's not correct. We want to print out number 5, right? So in this week, we're going to touch on how to really manage some of the areas, the issues that's in the program by looking at exceptions. In other cases where we would have different type of errors, for example, like if you're trying to divide something by 0, right? That's against the rule. So when you do 1 divided by 0, it's going to throw an exception. Okay, so let's say that I have my num is, let's say 7. Okay, and I wanted to do num divided by 0. And it's going to show something like this. It's going to say that it's a 0 division error and you cannot divide by 0. So in such case, how can we track that and manage that and control our program so that way, you know, it just doesn't just halt, right? You don't want your program or your application to just stop. We want to be able to do something with it, maybe, you know, or when you're calling a function that's not valid, right? That can create some kind of issue. So we're managing these issues by manually program this in. So in the textbook and also in the notes, it talks about, you know, how the compiler really sees all of this and what kind of information it's giving you in the shell or in your console when you issue that type of statement. So as programmer, what we want to do is we want to take a look at the issue, okay, and we want to handle the exception as it is raised, okay. So in Python, like other languages, you would have some built-in exceptions, okay. Like in other languages, you would see catch and try, right? And in Python, you can utilize some of the common exceptions, and these are finally, assert, raise, try, and except. So I want to highlight try and except first, and then we'll come back to the other one throughout. Okay. So when you see an error, what you can do is you can implement in your program try and except. This you can tell the compiler, the interpreter, to try a block of code, and then it is then recovered. Okay, so the example that we see here is that first you have to import CIS, and this is a module for specific exception. So in this case, what we want to do is we want to handle the type error, right? You notice that in the random list, it's assigned A as part of the string is a string, 0 and 2. These are integers. So you have a mixed type in the random list. Then we have a for loop. And inside the for loop, we incorporated what's called try. So what it's gonna do is gonna take this block and it's gonna attempt that block when it comes across errors. Okay, so we want to say print, right? Try, the entry is entry R is 1 divided by integer entry. So we know that it's not going to have a problem with the value 2 here, because 1 divided by 2 is just going to give you half. But when it runs the 0 as it loops through, it's going to generate an error. Okay. In that case, when we hit the 0, it's going to say, oops, it's going to output this, and it's going to find the information on that error. It's going to know that this is a type of error and it has occurred. And it's going to print the next line, next entry, and then that will be the block that it's going to use in the case of an exception. Okay, so now if it comes across the 2, it simply shows the reciprocal of 2, which is part of the main for loop there, So when you run this, you're going to see this type of output, and I'm going to run it so you can see. So when it loops and it reaches the 0, it's going to say, oops, right? 0 division error occurred. Or when it sees the string, it's going to, because we have it parsed as integer when 1 divided by the value in the random list. If it's a string, it cannot divide that by a string. That's a type error. So it's going to say, oops, that's a value error, right? Next entry. So it's going to go to the next one. So as you can see, this is a good example for type-based errors. Okay, and then the 2, it's going to run just fine. Okay, all right, any question? So Michelle said, is another reason for doing exception code is that the trackback message does not show. Yes, and what we want to do is we also want, yeah, you want to manually track it. So because the trace back is not going to give you the complete detail, and also it also depends on, you know, how your debugging library would be on your IDE, but in Python in general, we wanted to make sure that we handle exception. For different reasons, and some of the areas as you mentioned, that is correct. So let me get my idle open here, or I can just simply open it in, actually let me open it in Tony so you can see it. Instead of, you know, bringing two of the window together, it's just better for me to run it in Tony, but you can use idle as well. So in the, oh, I think I have the wrong, in the example, the try example, this is what you see. Okay, so we have the random list, we have the for loop to loop through, and it's going to plug in each of the value, take 1 divided by that. But since we parse it int here, it's going to throw an error. So when we run this, oops, right, it's going to show like what you see as the output there. Okay. Now, the second way that we can do this is, instead of using this, what the notes tell you is that what you can do is you can use the object, which is E. And since this is a class, what we can do is it's part of the exception class. What we can do is we can bring forward some of the information, right, to be able to handle the exception. So it's still going to give you the same type of information as the output in console or in shell. But what you can do is you can use the object in the class. Okay, so I'll bring that up so you can see. So this is still, we still have the random list, but in our try, right, we still have this. Notice that you also need to have the break statement there. Okay, in the prior weeks we talked about break in the condition. Okay, now unlike the other one, you can see here under except, you would state, right, exception as E, and we want to use the namespace class with the E as the object to bring forward the information or to print the information about that exception. So you can do it this way, or you can do it this way. But notice that we have on both of them, you have to use import.sys. Now, Python indentation is important. I want to mention that to you because things will work if we properly indent it. If we don't, it's not going to work appropriately, or it even generates an error, right? So under our loop here, what you notice is you would indent the try, and after the try, you would use a colon. And then after the except, you would use a colon. Okay, so the body of the block, you can tell it to do something there. So in this case, what we want to do is we want to show what kind of exception. And then we also, after it breaks from the try. Okay. Now, without the break, sometimes it cannot move forward. It depends on the exception that you come across. So what you want to do is you want to break from that so it can get into the accept area. Okay, any question? Okay, so in our first questions, it asks you, why do we use exception in a program? Basically to handle errors in the program. And you know, beyond the beginner introductory errors like syntax, we really wanted to handle the type of errors that could possibly, you know, in the categories of the runtime error. That's what you want to really handle. Okay. Any question? Okay, so you see how try and catch is, or try and accept is used. Sorry, I'm so used to some of the other class. But we want to be able to handle this type of error, right? Like in the shell. So in your notes moving forward, it shows you how you can also use pass, okay, to get it to the next section. So what we can do is you can use try, do something, and then you can use break or pass. So you can pass, and then under accept, we want to specify, right, or use something to mention about that error and then how we handle that error. Okay, so that's another way to implement it. Okay. Do you have any question for me? I see some people writing this into the chat. Exec info in the sys info line. In this one, right here. So what that will do is it's gonna go to this module and it's gonna find the information about that type of error. So in this one, what we did was we utilized an object, right, to really reference that instead of using this. So this is a method or a function actually, and this function is gonna access, it's part of this module. So basically you're calling a function from that module. Does that help, Michelle? So this function identifies the type of error that's generated. So with the 0, because this is, remember, a list, so we have to use the index there. Okay. Other questions? Okay. So I thought I added that to the notes. Let me see which area that you can find that information on. Right here. So it to refer back to the what Michelle was asking, right? If you go to page 2, it talks about that. So when you print, you want to print the name of the exception, you simply use the function from the sys module, which is exe info. And so that way we want to see what kind of error that will cause from that. And that was in the try block for the first example. Okay. All right. So let's take a look at the race before we start writing this next program. Let's take a look at race. So in Python, it tells you that exceptions are raised when errors occur at runtime. Okay. We can also manually raise the exception by using the keyword raise. Now, we can also pass the values to the exception to clarify why the exception is raised. Okay. So in this example, you have a try and we want to print 1 divided by 0. We know that that's going to generate an error. In the except, we can raise, and when this is raised, when that occurs, so when we have the runtime error, then it's gonna print that string. Something bad happened. So let me run this so you can see. Okay. So if we run this, you notice that unlike the other one, because there's not a lot that we program it to do there, if you look at the output here, right, it's telling you that, yeah, this was raised, and it tells you that something bad happened. And notice on Tony, I'm using Tony, it shows that in red. And in idle, it also shows that in the shell on how that is detected. Okay. So it simply just tells you that this happened. So it executed this part of the race, but it did show the error. Okay. So that's a way that we can manage or handle the exception by using raise as the keyword. What triggered the exception inside the code? So so we want now when you're using the raise here, it simply showed this, that under this error, it's going to print this. Okay. What triggers it? This. So when it comes across 1 divided by 0, so I just want to show you outside of that program. Okay. So if you take 1 divided by 0, you would get 0 division error. And that's part of the runtime error. So what you have is you want to be able to, when it tries this, right? When we tell it to try that, in the except, instead of us saying, some of these conditions, what we want is we want to say that race, and we want to print something bad happens. So in the trace back, it's going to see that this was raised as a runtime error, and it's going to print something bad happened. Okay. Now compare this to the previous program. We didn't have anything raised there. So when we ran the previous program, it's still going to execute what we tell it to do here. Okay. It's going to break from the try or pass from the try, and then we can have it break or pass from the try, and then it's going to execute something there. Where in the race, it's going to bring up, right, whatever we specify as the error there, and whatever we want to show or display in the case that we do. Okay. So now, why do you want to use this? Okay. I think I stated that here. So what we want to do is you can manually raise it up and show that this is the error. So you can have it raise and then do something there. Or in most part, it's not commonly used compared to what you've seen with try and accept. Okay, for the functionality of applications, we tend to really utilize it in a way where we would just have it when it comes across that either it moves forward and it shows something, or you don't want it to be stuck right there. With the raise, the way I had it, it's only going to show that part, and that was the end of the program, but it's just going to be stuck right there.
So it's like is it like a quality assurance thing where
Yes.
you're going to have this error in this code, so you're just preparing ahead of time for it?
Yes. So it's all about preparation, and that in some cases you have to use that code, right, to get your application to work, and you have to overcome some of the challenges in that code. It's also used for debugging, right? In the case where and companies will buy code from external sources. So when you're given that, you got to make things to work with your internal existing application and system. So what you will have to do is you can utilize the built-in exceptions to be able to overcome that. Yeah, so you should have that kind of expectation. You're correct. Okay. Now, when in the case of input validation, we should expect the user to fat finger the key and type in the wrong thing. We should expect the user to enter things outside of that range that we want the user to do. So with that, you have to handle exception. Okay, and that's important to really see when you're planning out and designing your program. You have to think about what could possibly be outside of the scope. And with that, we would implement a section where it would handle the scenario that's outside of what we want. Okay, and that's the whole purpose in this, is not just to find your own internal error, but it's really find especially when you're handling input from the user. Okay, all right, so you see how that can be, it's just simple how we can implement this. And let's look at this one. This one, it asks the user to enter a number. And this one we're using assert. So it's a way that we can implement assert to debug. So the assert, it allows you to test the condition. If it returns true, then it's gonna go to the next part. But if it's not, it's gonna raise an exception, right? So if it's not, the program will raise a specific exception. So if it's true, okay, so this program is designed to give you the even number. So if the number is divided by 2 and the remainder is 0, right, then it's going to show the reciprocal of that number. If it's not, it's going to kick it here. It's going to show you that it's not an even number. Okay. So let me open that up and run it so you can see it in action. So this is the exact program that we're talking about. Let's see, we're gonna go F5. So let's say that I input a number 3, which is an odd number, right? See how it goes here because it's an odd number. Now, if I run this and I give it an even number, let's say 20, it's gonna take a reciprocal of that. So the assert allows you to check the condition. And we can say, we can specify the criteria or the condition here following the assert keyword. Now, if it's checked true, right, it's gonna go to the else section here. If it's false, it's gonna go to the except section. Yes, it is. It takes place of the nested if. That is correct. So you do have if else condition that's incorporated, implemented with this small program. And the assert is just, it's going to return true, right? If it's false, then we want to go to the except. Okay. So this is another way that you can implement try and except with assert. Any other question? Okay, so the example, you would see that there on page 3, I showed some of the output. And then if you put in the 0, right, it's gonna throw a division error. Because when it takes this reciprocal, 1 divided by 0, it's because 0 divided by 2 is 0, right? And then it's going to take a reciprocal of the 0, then it's going to throw an error. So then you're going to have to handle that next level from there. Okay. Another way that we can implement the exception is to use try and finally. And so in finally, it forces the program to continue in the next part. So now if you look at the program I have here, I have F is open test text read, and this file doesn't exist. It's going to try to read the lines from the file. It's going to try to execute that. It's going to close, okay? And then we're going to print, we can print anything. We can print done, right, in that case. So what happens is, even if this file doesn't exist, it will go to the next part, okay? So let me open that up and I'll run it for you so you can see. So I'm going to change this up. I'm just going to say finish, so it's not confusing to you. Okay. See? So what this is, we don't really have this, right? And so when we do this, what will happen is it's still going to go and it's going to try to read something. It's going to close and it's going to print. Now, if you look at some of the web example, they showed this example being done, but I think it was done incorrectly. If you add this statement under here, under finally, it's not going to be able to close because it's going to tell you, it's still going to see that error. So let's say that I take this, okay, and I put it under finally, like this. I'm going to save it, I'm going to run it. What will happen is, let me see, add an indentation, sorry. Let me fix the indentation for the print there. Oh yeah, so when I put this here, it's still gonna finish and it's gonna close, okay? Now I'm going to show you my file. I have a test file. Let's say I delete this. Okay, let's run it again. There you go. No such file, test.txt. Okay, so ideally what we want is we want to be able to catch these things and to be able to have an expectation of what will happen. So I'm trying to read a file that doesn't exist, and I'm trying to close it, and I'm trying to print finish. What will happen is it's going to tell me that this file doesn't exist. Okay. Any questions regarding this? Okay. So let's look at what we need to do next.
I tried running this in my idle, and the only way I could run it was to put the file open in the try block.
Yes.
But you have it outside the try block.
Let me rerun this. So you're saying that I put it here? Yeah, so make it local. Make it a local variable or object.
So how is it you were able to run it outside of the try block?
So for earlier, I had the test file open. So let's see. Name F is not defined. So when you put this inside the try block, it becomes a local, and it's gonna create issue there. Okay, so let me put this back. I'm gonna make sure that I don't have all the indent. Yeah, I think you have to pass it from this point. Let me see. And close. Let me comment it out. Hold on one second. Yeah, it's gonna be a runtime error. And for that, no such file directory with the test file.txt. So we have to probably append or do something with the try to get it to get to here. It's not gonna let you do this. Yeah, because I originally, when I tested it before, I must have created the test file, and that's how it's able to run it with that. Let me run something else. I did a test for one of your assignments for the number 4. Let me see. It's a similar program. What was it? Number 3. Let me double check. Okay, so you see that I have no file there. Okay.
So here you have it inside the try block.
Yes, I have it inside the try block. And then when I run it, it says, but I use except on this one.
Is there a difference? Because one is here you use read, and then the other example you use read lines.
Yeah, so in the other one, it's supposed to go through and read each line. So if let's say that I change this to read lines, let's see what it will do for you. It still does it, no difference. Because read lines is just gonna read with all the formatted string characters, like new line and tab and all of that. But with read, it's just gonna read from beginning to end.
Sorry, I missed it. What? So how was it that the first example you were able to run it without the red trace tag, and it was outside the block?
Let me go back to that. Let me put it back and see. And then I will go ahead and close this. Let me see if it runs it now.
The F open line was outside the try block.
Yeah, what I moved it into the inside because on this one I have it on the inside and it's still not able to do that on the finally. I think you have to control this part and do finish. Let me see if it does, if it will close back here.
I guess I'm not sure. I mean, this example uses finally, and then the homework one, if you use accept, it works.
Yeah, you use accept, it works. Accept will get you to the next section in the finally what it ideally what that you want to do is you wanted to get to move on to that part. Now the way that they show here is that for the finally the clause is executed no matter what in general release of the external resources. But when we test it and possibly so it halts. Okay, so in the circumstance if you want to halt finally, I tested it now with the file, it's still gonna halt that. Let me play with this a little bit more. But yeah, so it read here with the except for me. And I have it, you saw that I move it back into the try. But with this being outside, right? Because it says no such file, it's still gonna see that. Now, if you change this into, of course, we know that if we have it written or a pen, then it's still gonna go. It's gonna allow you to do that. Okay. But with this, what happens is, let me see if I can. Yeah, so when I change this into accept, it's gonna want to see that this is a global. F is not defined, and I put it down here as F close. It can't execute that. Okay, let me move this over here. Now it does it. So with accept, it's gonna be able to get to this section with the close being up here because the F is declared here locally. Okay, now with if we change this to finally, right, it has to run this part in the try. So the try has to go. Okay, so that won't work because if you think about the interpreter, it's gonna go line by line, correct? So when it gets to here, it's gonna it's going to generate that error, it won't be able to get to the finally. So that's why we get this error first. So the program stops when it gets to this part and this part. Okay, these two methods right here, it won't be able to operate those methods. So that is falling back into the compiler error before it gets to the runtime error. And finally, if you handling it with the runtime error, something that would, so where you position that, and let's say that if we move this over here, right? Then what will happen is we have to take the F and put it above try, and we have to print something there. Because now what happened is it needs to see this object in the finally section, in that block. So let's say if we print checking. Okay. So you see, it's gonna be right here because it's outside of the try. It's now gonna still have the compiler error using finally. So where you position that statement is important. Number one, just to go back, this allows us to globalize what F is. Number two, right? If we take the methods, the functions outside of the try, and we're making it operate and finally, it won't get there because it's gonna get stuck right here. Okay. So in this particular scenario, it's better to use except, like what we would see in, I'll show you what that would look like for number 3. Okay. So for number 2, we have to write a program that uses try exception to handle concatenation error for the following string. Hello 5. The program should print this is the type error. Provide script and output. So just to test it before we even attempt writing this, if you do hello, right, plus 5 or any value, you would see that this is a type error, and I'm just simply running shell for that. And it tells you that it can only concatenate string, not integer. Now, if we do hello or hi, right, plus 5 like this, then they will say high 5. Okay? So we know that if we have it with the integer, it generates an error. So what we have to do is we have to be able to do try and except to handle the exception. So for number 2, right, I'm doing something similar because Chris tells me, you give us all the exact answer. So I wanted to do something a little different so you can see. So first, we want to do.
Thanks for putting me on the spot. not everyone's gonna hate me.
No, everybody loves you, Chris. But you know, your feedback is important to me because I understand that, right? Like I take that feedback and I said, how can I do better to make sure that my student applied the programming concept instead of just giving them all the answers? So we wanted to look at, you know, an example and something that I'm doing close to that, so that way everybody can learn. So you can take a look at this, and if you apply it, you'll be able to get number 2. So first we wanted to put import.sys or import sys, because sys is going to give us, the module is going to give us the information of our error. In my try, I simply put str is hello world, and you can name your variable anything you want there. And then I'm going to print str plus 25. Okay. And except I would have print sys.exe info. So we call on this function from the sys module, and we want to say that error occurred, right? And then we want to print this is a type error. So let's run this. So here what you see is it tells me that this is all class is the type error from that module. That's what it pulls the information, and it tells you in detail. It can only concatenate string, not integers. And you saw that when we pulled that from idle as well. Okay. And so for the traceback object, it's at this location. That's the memory address. Okay. And then it's going to execute the next line and accept print. This is the type error. So you can do something similar to this for your number 2. No, we don't, because it's not in the list format. So you just have it state however you wanted to display the information actually for print. So what I wanted to show you what kind of error it is that it found in the module, right? And it's a type error is a class. And so, and it's in that class, that object, the type error object in the type error class is located in this location. And that type of information is important because sometimes you wanted to know where that is physically. Okay. Any question on number 2? So this is a very easy one to try, and so you can see. If there are 2 or more errors, you can if you tell it to print. So let's say that I change this, right? Let's say that I print like this. Okay, so now on here, what I have when I run that without this, okay, see, it only gonna catch the concatenation issue with the string. So what we have to do is, if you wanted to have more, remember you're still pulling this from the attributes of that object. Okay, it's only going to show one time if we print this here. Now let's say that if we do print sys.exe, say we comment this out. There you go. So it's still going to only go back and it's going to say, oh, that's a concatenation. So here is where Andrea had asked earlier if we really need to be able to associate it, that with something else that would be in a list format. Because we're only going to have the concatenation here, it's going to still print the same thing over again in the info. So you want to be able to specify what that would be as it would try here. Okay.
So it didn't print the second error then?
No.
Do you think it's because since the program did not finish doing it, it stopped there?
It just only operate here. And so when I had print, right, 25 divided by 0, technically it should get to that point, because when it gets to here, it jumps over here. Okay. So when it saw this exception, it's going to go, oh, it's going to show that print because you tell it to.
Okay, that makes a lot more sense.
Okay. Because when you get to this line right here, right, it's going to go to accept. And this is ignored. Everybody got that? Okay, Michelle wants to do print. So what if you put continue after this? Yeah, so it's not part of the loop. So what if we convert it, right? Oh, before that line, you want it. So no, it won't. That I won't do that. Let me see if we can. Yeah, it's still gonna want to get to here with this. Let me tweak this a little bit and see. Yeah, it doesn't like anything there. It needs to be at the end. Oops, sorry. Nope. Yeah, it's not. So I think you have to handle each exception individually. It doesn't allow you, because remember that it's seeing that as an instant. It's a part of that object. So it's gonna try to only handle each of the instance individually. And in this case, you know, so you can't we can possibly make it where it stores it into a list and then and loop it. You can play with it that way, but it's not going to be able to separate this from this. Okay. Question? All right, so no question. So what you can do is you can, I'm just gonna comment this out because when I do the winter lecture, I'll mention that. I'll come back to this. And so when we run this like this, yeah. Go to accept, print. Oh, I had changed it. There we go. That's what we wanted. for it to go to accept and then print. Okay, that was number 2. Any other questions? You had a glance at number 3 before. So before we move into the class and objects, we want to talk about how to do the file error here to handle the exception here for number 3 and number 4. So for 3, it says write a program that reads file1.txt, which does not exist. The program should print this is an IO error. Okay. So here is my number 3. And so I have it, file is open file1.txt and read, file.read, close, print IO error. Now, we mentioned earlier that this, as you declare it, since it's local, you have to operate here in the try. And if we take this out of the try, it's going to throw a different error. It's going to say that it can't identify what file is. You can name it whatever you want. So if you name it F, it cannot find it. And that's what we seen in my example earlier. Now in this one, I didn't use the information from, so I didn't have to import sys module because I didn't call on the function there. I simply just wanted to print out that this is an input output error. Okay. So when it gets to this line right here, what it will do is it's going to jump here. Okay, let's go to set block. And that's why that gets executed. Question?
So if you do have the file name file1, it does not execute the accept block?
What you can do is you can append something to it and see. So if you, let's say you have this, right? And then let's say that you append something there. So let me test that for you so you can see. Okay. So let's say that I have this as write. Okay. And I'm going to go ahead and do an append. This is a test. Okay. And then it will, now everything here generates no error. Chris, is that correct? So when it generates no error, it was just gonna do read and close, right? After it, so let's say that we seek it, we read it and close. Okay, because at this point when we read it, it's just gonna be blank because we write to it. So now it's still gonna go here to print. Why is that? What do you think? I think this is gonna make it an error because I have to have except with try. It's still gonna go through and it's gonna run line by line. It's gonna get to this point still. Okay. But if you have an error on the specific line, it's just still going to jump here anyways. That's how, yes.
So if you put a break after file close, would it break? Oh no, so it break does
Yeah,
not.
because try and accept is designed to check each of the line and then go here either way. You see what I mean?
Yeah, okay.
Yeah, so like,
it's gonna
yes.
it's gonna execute every line no matter what.
Yes. Or attempt to, right?
Yeah, or attempt to, yes.
So if I don't have that file exists, it's gonna try to get here because that's what the structure of that's what it's designed to do, is that it's gonna run through these lines, and then in any case, if it comes across an error in each of the statement, it's gonna get to the second part of it, which is accept. Okay, now you can get it to get out of a certain part of that try statement by using other statement, like what you've seen in the first example. But in this case, what we want to do is we want to get here, because that's the whole point in handling exception, is when it comes across error, then it sees it as an exception.
Okay, makes sense.
Okay. Question, other question. So you can play with it and test it so you can see exactly what it's doing at each line. Okay. So for number 3, we simply just gonna output IO error there. Okay. For number 4, we would use assert, write a program that prompts the user to input a number, use assert to handle exception for any value that is not 21. Provide screen capture for script and output. So in the case where if you want them to put in specific value, right? Like, you know, so, or a certain format, whatever, you can use this to really check for that. This is number 4. I think I have 4 open somewhere. Okay. So for mine, I chose to use 500 instead of 21. So number 1 have the num and it's parsed as integer input, enter a number. Assert num is 500. We want to have accept, print number is not 500, else print you entered this number, okay, to validate. So let's say I put in 20, right? It tells me that my number is not 500 because now it becomes exception. Now, if I run it again and I put in 500 and it says I entered 500. So you can see how assert is used with try and accept. And you know, you see application with this quite a bit when you're looking at input validation, when you're looking at controlling specific, you know, value for your data. So this is definitely useful. Okay. Any question with assert and number 4? So like what Andrea asked earlier, yes, it's like having an if within.
So we could use this for our programs last week, huh? This would have made it a lot easier because I have a lot of errors. Well,
right.
they're correct, but if I wrote something different, it would have broken the whole thing. It breaks the whole thing.
Right. So you could, so our lab last week was a little mini project for you, and I wanted to see if you can overcome some of the things that challenges, because that take it into, you know, business application, you know, area. yeah, you can definitely implement this as part of input validation. So that way, if anything that they enter outside of that scope, right, it just doesn't stop your program. So yes, you can definitely do this. And so in the future, when you see a requirement like that, you should think about how you can implement, how you can handle the exception in the program like that. Okay, and hint, hint, project, that's what I'm going to look for as well. So, all right. So here's the number 4, similar to it. And then we use try, assert, accept, and else. Very similar to the example in your notes. Okay. And the whole point is all of this, right? All of the weeks that we've been through glued together, and you have a big picture. And I want you to walk away from this class having, like, you know, at least the beginning of your program without the major data structure, but, you know, at least some of it worked out. So you can build on it, and down the line, you know, and that's the whole point of putting together things for your portfolio online, for your GitHub, is to take the things that you write and be able to improve it and share it. Okay. All right. Let's talk about the next one. Write a program that contains class object calculates volume of a rectangular box given that its length is 20, width is 10, and height is 5 inches. The program should contain class and object, and the volume is length times width times height. So before we start working on that, let's talk about class and object, which is in chapter 17. So moving away from handling exception, we need to touch on class and object. And then after this, we would look at multiple classes and parent and child class, or inheritance, and in the polymorphism. So that's the last part of this class, okay? And then we will work on the project. So an object could contain variables or methods, and you would use a variable, and the methods are the function that would act on the data that's inside the container, which is in variable. You can use list too, okay? A class is basically a blueprint of the object. So a class is like an outline, a prototype of the actual house, a blueprint of a house. And what we want is, we wanted it to contain some details, right? Like, where's the door going to be? How many floors is it going to have? What time, you know, how many windows, etc. So based on the description of the house itself is the object, and that's the analogy. Okay. So before you build the house, you have to have a sketch or blueprint or prototype of it. So that's what the class offers. It's going to give you an outline, a sketch of your object. Okay. Now for the class in Python, you're going to use class as the keyword. And what that will do is it's going to create a local namespace and the attributes that's defined. And similar to what you've seen in Java and C++, right? You have a class and then its name, and under that in C++ you would have the member, right? The members, which are the variables of the container, and then the member function, so you can have it incorporated in that class. So what that will do is it's going to outline, right, the attributes and the functions for that object. Okay. Any question? So what we can do is we can, in that class, we can create an object, but when you define the class, what it will do is going to create that class object. And you see this more apparently in Java. So, you have to name your class and your file name the same. So that way it would convert it into, it would create that class object. And the same thing in Python, but we don't have to name the file exactly as the class name. But when you define it like this, class person, what it will do is it's going to create that class object called person. Okay? And what we will also what you can do is we can create new objects inside that class, in that class. Okay? And so what you would have is not that you only create the blueprint for your house, which is the object, you also need to create instance for that object. Okay, so when you create that class, you can create the object, and what that will do is create the instance of that class. And this is what's called instantiation. So if you take a look at our example program here, we have class person. And with Python, what you will do is the members are under that class, like name and age. You have to use, right, this, you have to define this function. Okay. If you don't, you can also use the self keyword, and I'll show you some example with that. So this allows us to have the initiation of that object. Okay, that's going to be created down the line. And so this is going to be the instance for these members that we're going to use. So what we do is we're going to define this function, and then the first parameter here is going to be self. And self is a way that we can reference the current instance in that class. It's used to access the variable inside that class. Okay? And so basically it's saying that these variables have membership in that class, like what you see with C++. So these are the variables for that class. That's what we're doing. Then what we will also have is also, I might have repeated twice there, sorry about that. But the self here is a self is a keyword, so you have to type it as self. And it can access the attributes and the methods for that for that class. It binds the attributes with the given arguments.
And it can be anything, right?
Yes, it can be anything.
And it has to be on the very first one.
Yes, it has to be in the very first parameter. So you can call it A, B, C, but most of the time you see that they use self as in practice, because that would just, make it easier for you to see. If you look at example online, you would see that likely they use self because that, it's the way that they document it. So it's easy for you to identify it. Mm-hmm. So here what we have is we would have self name is name, self age is age. So basically we're saying that name and age are the member variables of that class. Okay. Then what we will do is we will create the object. And when you make an object, you can call it anything you want. Often that you would see that they would use like a letter, like P and a number, or just a letter. It's okay. Like what we've seen with E, right? Or F. We've been using it all along. Okay. So what this is, you can create an object, and all you have to say is that you bring down the class name. okay, which is person here. What that will say is this object belongs to this class, okay? And inside here we have the arguments that's going to be used for attributes in that class, okay? So when we print, we can say print and then the object, and then following that with the member or the variable, which is, it's going to bring down the attributes here. So it's going to say print, right, Jane, print 30. Okay. So this is one example. What we can also do is we can also have a method for the object. Okay. And so just like how you would define, I might have had it out of thing there. You might have defined your function. Previously, we learned about functions. So you used to have to start with the def, and then you can call it anything you want there. But importantly, you would bring whatever you use here. If I use self for the first one, I need to bring that down here. Okay, because what that will do is it's going to tell, right, the interpreter that this is a function of that class, and we can use it as a method for an object, which is a function for to operate on that object. Okay, so with this is that we can print, right, in this function we're going to print the name and the age.
So for that one, could you just leave it name? Cause since you're, oh no, that's reassigning it. Never mind. Just
Right.
kidding.
Yeah. So you don't want to leave it as name, right? You still have to tell it that we're using a variable from that class by using self.name. Okay. So if you call this ABC, then you have to say ABC.name, and you have to specify that here. Okay. All right. Then down here, you simply would use the method with the object. So here what I did was I created the object, right? And with that, I would have these arguments that would be for the attributes of the object. So what I have is right here, I bring down the object, and then I would have the function, which becomes the method for that object. And I call it. Okay.
So it's similar to C++ without having to add the new, right?
Yes. That's correct. So now what you can do is once you create the object, you can change the value or what's inside that object, right? We don't have to be stuck with one object forever. Then we have to create other objects. So no, what we can do is we can update it, right? Because it's still a container. What you can put in it is really up to you. So you can reassign it. So instead of 30, once I have it printed out 30, if I don't like it, I can print it out 40. I can have it printed out 40, right? So I simply just reassign it and then reprint it. Okay. Now, Python does okay. Thank you, Michelle, for sharing. Python does do garbage collection. Okay. So if you created the object and if you don't use it, right, it gets deleted. But if you want to know how to delete the property of that object or the object itself, you simply use del for delete. Okay. So let me show you the class example. So here's that first example. And then I would run this, and it reads Jane and 30, right? Because we have it print Jane and 30. Okay, print P1 name, P1 age. Then what we can do is we can add in, right? We can define a function. Question? Let me show you another example. Okay, so here's another example, right? I have a class called dog, and I have attribute 1 or ATR1 and ATR2 for mammal and dog. Then I have a function called fun. And in this one, you notice that I didn't define the other function to specify that. But what I do is I can just say self, and I would be able to print self.attribute 1 and 2. Then here created an object. So object instantiation. Then we would use the object, okay, with the attribute, and then call the method. So it would print mammal. Where is that coming from?
Line 19.
Yes, thank you, Chris. That one. Then, yes, Chris?
I just turned on the thing. Nothing.
Okay. I am a mammal and I'm a dog. That comes from when you call this, right? It's going to come back here and it's going to print those. Okay. So this is another way to do it. But, you know, if you wanted to structure it properly in your Python program, we should define the other method, but you can use it this way. Okay. Let's look at another example. Okay. So here is an example of a class that's called car. Okay. And
oh, okay, now I get it. So I was wondering why you had attributes and everything, but when you for the other example, you already what's it called? You named the attribute here, and then on the new program, on the new one, you're assigning the attributes outside in 9:14 and 15.
yes.
Okay. So I was just getting a little bit confused, but now I understand it.
Okay. So in this one, right, I had declared at the top, right? You see that as variable here, and in C++
Yes.
we call those a member variable, and we simply bring that down here to print. On the example 3, right, I don't have declaration of the variable, so I can just tie it back into as object. Okay, I make it as an object here, each one of them. Okay, so in the case, if we go back and fix example 2, what if we have dog and cat, right? Then what you can do is you can fix that. Instead of declaring the variable just about dog, you can separate them by creating dog and cat object and be able to apply the appropriate method for each one. Okay, so in this one, in the class car, I simply just define the functions. I have a function that's going to show the model and the color of the car, but I also have the standard instantiation function for it's, which is a constructor function for model and color, which I'm going to use in the second function. Then line 14 and 15, I define my object. And I'm saying Audi is an object within class car, and use these attributes for that object. Okay, like Chris said, instead of declaring it up here, what I did was I make it into an object, and I use the attribute with those objects. Then for the Ferrari, which is the second object, that's part of class car, and I'm using these attributes for the second object, Ferrari. Then on 17 and 18, I call, right, this function show, which is supposed to print out the model and the color for each of the object. And I use, when you do that, it becomes the method of that object. So this will still output the same as car.show Audi, car.show Ferrari, like the other one. So when we run this, right, it tells me that the model is A4, which comes from here, and it's blue. And the model for the second object, that's a Ferrari and green. Okay, so that's another example that you can see. Question? No question. Okay, so now you started seeing some example. Let's take a look at the things that we have to do, and we can wrap it up. Okay, so there are two more programs that we have to write, and they're short. So number 5, it says write a program that contains a class and an object that calculates the volume of the rectangular box, 20 by 10 by 5. The program should contain the class and an object, and their volume is length times width times height. So instead of doing a rectangular box, I did a square, which is almost the same, but you can see it. So let me show you mine. So what we have to do is first, right? So let's talk about the approach in this program. So what we would do is the A, we would define a class, and you can call it anything you want, okay? And within that, what you will need to do is you can use the first approach, which you would declare member variables, right? And assign value. Or not. If you don't use that, you can make them into objects, right? And then you would declare define functions to operate on the variables. And then we would define object, or use method to operate on object attributes. That's kind of like the layout that we have to do right now. Okay.
Since we know the input or the variables, the value of each variable, should we just do it declaring the member variables and assign the values instead of doing the object?
Easy? Yeah, if that's easy for you, perfect. Okay. So since you already have that, Chris suggested that we would use the length, the width, and the height that's given, right, as member variables in the class. And this is number 5. So it's not exactly like mine, right? I'm using a square instead of a rectangular. So with the square, the width, the height, and everything is still, it's the same, right? And the volume of a square is, or a cube, I should say, a volume of a cube is the width cube, right? You multiply it you multiply it by itself 3 times. So what I have is I have a class called box. You can call it anything you want. And what I did here was I specify what that class is. You don't have to put that, that's just the detail about the class, information about that class. That gives, it's going to tie it to the namespace of that class. And if you wanted to print it, it will print that information. And then I declare my member variable called width, and I assign it value 13, which is the inches that I chose to use for the width for this cube box. And I wanted to find the volume, so I just initialize it as 0 for now. So I had a function, I created a function called bvol, which is box volume. And in the parameter, I use self. And then what I would have is I would specify what the volume is. So here I would assign what volume would be, or operate on the volume. So that will be width to the cube. Okay. And I didn't want to use like the math library, so I just simply use the operator. So if you use the asterisk like this, it's just gonna multiply by itself 3 times. And then I want to return the volume value. Then I created an object named B, and it's an object of the box class. And then under that, I would print, right, the width of it and the volume of it. Okay. And my width is 13 and my box volume is 2197.
So in this case, we don't need the whole
the other function.
Yeah, the def. Yeah.
So I wanted to show you that you can do without it, but by technicality, Python 3, you should do it, because in the case where if you have many member variables, right, we wanted to make sure that we include all of those, and it gives you a self-checking process and to kind of lay that out for the class. So it maps out all those variables for that class. But yes, you don't have to use it. I wanted to show you that you don't have to use it. You can if you, and by technicality, you should. And on the next one, I'm going to show you the implementation of that. Okay.
Okay.
Question?
So I got a question about the whole. So is this? Are we gonna create it, like the classes on a separate, like their own class? Get what I'm trying to say? It's like for example, box. Are we? So are we gonna create a file just named box?
You can make a module named box and import in that module. Okay. But yes, you will in the next week we will do multiple classes and hierarchy in the classes, like parent, like the super class, and superclass, and then you have the subclass. We will use that next week. Yes. But if you wanted to, you can, we learned last week how to make file. We learned last week how to make a separate module to work with our program. So yes, you can do that. And then you can also have a class inside a module. Sure, you can do that as well. You saw some of the module that we've been using, like CIS and the other module, they all are class. They all have classes. So yes, you can definitely create a module with class. Okay. Now, Michelle asks, why is this one not using? So because with the way that Python is, right, if you don't use it, it's still going to see this. So what I'm doing here is this is a parameter self. This is the argument that's used, and we can use this to implement it throughout. So it's still going to tie the container, right, to this. And then I will show you implementation, but in technicality, going back to Andrea's question, you should use the function to really say that this is a function which will become a method of an object in that class.
So in other words, so in C++, self is this.
Yes. Just another way to use that. Yeah. It's just so what we're saying is that we are referencing the members by doing that. Okay, we're saying that this member is part of that class, because when you start having class that are nested, you're gonna see that it's gonna become crazy, right? It's gonna be like inside, and next week we're gonna start seeing some of the nested class within and how the object's gonna work from the inside and the outside. Okay. If you had more attributes, wouldn't you be forced to use? Yes, you would use that, so that way it can reference, because you're gonna start losing when you have like some of the inside, let's say, object that's gonna work with the outside object, vice versa, then it's gonna have issues. So we want to be able to use that. Okay. So that brings me to the next program. So, you know, I like using these type of retail stuff because it's easy for you to see. A produce sells, I'm sorry for the vegetable, let's just say fruits on yours. It was late. Oranges, grapes, and apples. Write a program that uses class and object to determine the cost when the customer purchases 3 pounds of each fruit. Provide screen capture and output. So we want to calculate 3 times the price per pound to give us, you know, the cost of each of the fruit. So let's open this up. I did something similar, not exact, of course. Oh, let me show you. I wrote 2. Sorry. I thought I did another one. Yep. Okay, so this is the one that I wanted to show first. Okay, so I have fruits as the class, and instead of declaring all my price and weight as member variables, what I decided to do was I decided to make them as objects. Okay, so I can still calculate them separately. So that's why I comment those out. Here I would have the function that's gonna tell me what are what type of containers or variables that I'm going to work with. Okay, so I have here that I have self, and then F type is going to come from I'm sorry, I modified. Yeah, F type is going to come from the decoration here. So I wanted to say F type is going to be, that's going to mean fruit type, right? Because I have individual fruit as object. So self F type, the weight, and the price. So those are going to be the three variables I'm going to use: the fruit type, the weight, and the price. And then with that, I wanted to have a function to show the price, or show cost, that should say, but and then my total would be self weight times self price. 3 pounds times the price of each of the pound for the fruit. Then I'm going to print it. I'm going to format the total. Then I created the object pears, strawberry, and peach, each fruit as object. And with that, I bring down the class name, and I wanted to use these attributes with the object. That pears is going to be its name or its type, and the weight is 5, and the price is $1.10 per pound. Strawberry, another object under fruit class, the type is gonna be using string strawberry, and weight is 5, and the price. Again, for peach, same thing. Question?
Yeah. So, what if you? Because I'm trying to look into features for input validation. So what if you don't? Do you know how on initial you initialize? What if you don't have a value? Do you, or since you declared the values, do you have to have exactly like that, or can we have like a null?
Like an empty container, you
Yeah,
mean?
we.
Yeah, like a 0.
Yeah. For example, you have, okay. So I guess I'm getting ahead of myself, but if you put like input validation, or for example, when you put it on pairs equals fruits, you don't add the price. Would it still create the pairs, or would it give you an error saying that you need to?
Well, it's gonna store whatever the user's input. So you can, what you can do is you can, like in that case, I would declare the variable first. I would say pairs is gonna be right input enter the price. You see what I mean? Or enter the weight. So instead of using the fixed price like this, you can have, so whatever the user inputs, it's gonna store it into the pairs, which I'm gonna show you in the next one.
Okay.
And then it's gonna pass that down here. It's gonna use it as attributes. So at that point, that will be a different approach, right? If we declare the variables, the member variables first, we can bring them down and use that with an object. So I'm going to show you a second approach on this. So in this, I just use, what I would do is after I created the object, I just use the method to show the cost for each of the fruit. And you can do it that way, or you can print it this way, right? You can have it as fruits, show price, and then pass it in as pairs, because you had specified what that object contains, and that object would contain, it would have all of these attributes, and so it would be able to operate using those attributes. Okay, so when I run this, it shows two things. It shows, right, two sets, and it would get this same result. I have pears, strawberry and peach, which is this. And then I also have pear, strawberry, and peach, which is this. So either way, you're still gonna get the same output. So you can use it as a method of the object, right? Or you can pass that object inside the method for that class. And if you understand this, everything else would just jive together, because it's really about how we would be able to pull, right, data from different part of the load of the storage and be able to execute. Okay, let's look at my other example or exercise. So this is one approach, okay? This is the other approach. So going back to Chris's question, what if I have input here? Yeah, what I can do is I can store it to the variable and then use and specify that that's a variable of that class, and then use that variable to calculate the weight, or I mean the overall price. So here what I did was, after I had specified that each of these are the variable of the class, I created an object called F, and it's part of the fruit class. And I simply use that object to calculate my cost for each of the fruit. So when I run this, it's still going to give me the same outcome. And in this, I have it print, right, for what that variable contains. Question. We're down to the last few minutes. So either way, you would still have a class and an object. That's the objective of the requirement for the exercise. But, you know, instead of creating multiple objects, I've only created one object in this program. The previous one, I made multiple objects. And I use that object to access the method here, that I tell it to take the price for each of the fruit and multiply it by the weight. So I would get the overall cost for each one. Okay. Now, also when you start outlining your, how your program should flow, right? In the case, next week, we're going to talk about how we would have other classes within. Think about how your objects is going to work outside in, inside out, the inheritance, the hierarchy. And that's really important on how you would, structure all of this. And that's going to lead you into the last part of the Python, is the data structure. Any question? Okay, so you saw how this is done. You can go back and practice, just write class and create object and write, implement method with it. The more you do it, the easier it's going to get, because you're more comfortable with how it should look like, right? And how you can start seeing how the object works inside the class. And we will have more practice doing the lab. If you like, you can type your name into the Zoom chat. I'll stay on for a few minutes to address any questions before my next class. But I need to get off, and so I can get my things uploaded for my next class soon. But Any question?
Dr. Wen, I just had
Yes.
a question. I was just wondering, just to make sure I'm on the right track, the try and accept function, it's used to handle any unexpected error?
That's correct.
Okay.
Or expected error, actually.
Oh, okay.
Not just unexpected error. We know you would use that to handle possible errors. So we have some expectation of errors. So yes, you would use it for that try, accept, or in the case where if you wanted to do, you know, try, assert, and accept, so it can overcome some of the error in certain condition.
Oh, okay. And then we would use the, I know that I saw that it was kind of similar to the if and else statements, right?
Yeah, the assert.
Just the difference, right, is that if and else statements are just to kind of check something, right? If something's
Yes.
right or not. Okay. Okay.
Yeah. So assert is a way that we can implement a condition for a certain type of error. Like you can say, oh, if it comes to this error, do this. Like you can say print this or go here, right? So assert allows you to implement a condition for a type of error. Yes.
Okay. Thank you so much.
You're welcome.
Have a great day.
You too. Take care. Bye, Cynthia.
Bye. Take care.
No question? All right. Have a good afternoon. I will see some of you in the next class. Enjoy your afternoon. Take care. Bye, everybody.